so what we're being asked to do here is find a constant, that's c, such that the denominator will divide it evenly into the numerator. So if what do you know about that? Like what, if it divides in evenly into the numerator, what should happen? The remainder should be 0. Yeah, okay. So you could do this either way. You could do it by long division or synthetic division. But actually, before we even talk about that, oh no, that was this class that we did that yesterday. Right, does everyone understand when you can use synthetic division? You don't.
When you like a list of, you have to make sure which one's which one's not.
Well, as in okay, so flip over to the page and look at 17. Can you do synthetic division with 17?
No.
Why?
Because it's a quadratic.
Why is there any?
Can't you only use it when there's it can't be x squared or something, it has to just be 2 terms.
Yeah, so it has to be x plus something or x minus something, otherwise it doesn't work. Okay. So on number 44 here, we could do either one. We could do long division or synthetic division. I think synthetic division is the easiest. So let's set this up to do synthetic division. And so then what's going to go here? Okay, -2. And then what's going across from that?
1, 0, 0, -2, 1, c.
C, yeah, C. All right, so is that okay with everyone so far? All right, so here's the process again. You bring down the 1 and you multiply. And then you add and now you multiply. And now you add and multiply. And now we add and multiply. And we add and multiply. So then, what does C have to be?
42.
42. How's that? Does everyone understand why it's 42? All right. Yes?
But how do you know that it's not one of the ones that end up with a remainder?
We made it not end up with a remainder. We forced it. And so that's like what they're saying, like what would this number be here so that we don't have a remainder? Yeah, that's what they're asking. Is that okay with everyone? Is that okay? Your silence means yes. All right, so how do you do this problem? Do what? All right, so then, right, it would look like 2 to the 6 minus 4, 2 to the 4th, plus 3, 2 squared, plus 2. All right. Well, okay, can I just write it out? So 64 minus 64, so they cancel. Plus 12. All right, so are we happy that it's that? All right, I'm going to pause for a second. So, what's the obnoxious thing about this? Well, okay, yeah, specifically in this problem, the 6, but so what would be super annoying if you had to evaluate what? Yeah, that would be super annoying, or even, well, yeah, well, anything really would be annoying, right? A fraction would be really annoying, and also a negative number because you're watching your signs the whole time. Okay, and then this is fairly long and tedious. Okay, so now we'll pause. Yeah, right. So then if we do synthetic division with 2,
14's our remainder.
that's going to be our remainder, right? Okay, so let's just make sure it works. So it's going to be 2, and then it goes 1, 0, -4, 0, 3, 0, 2. And I would argue that this is much easier because it's pretty quick. So right, 1, 2, 2, 4, 0, 0. Oops. Yeah, no, I'm doing it right, aren't I? 0, 3, 6, 6, 12, 14. There. It's pretty cool, yeah? That's pretty cool. Well, at least that's as cool as it gets in math, really. Yes?
Where are you getting the 2 from?
So the 2 in this case is this value here. So what we just did was we evaluated this function at a certain point, but we didn't plug it into the function. We just did synthetic division. And so there's like these people, they figured out like, hey, look, every time we do synthetic division with this value, it's actually the same as plugging it in. And the point is that it's really quick and efficient. And so I keep telling you guys that this is used for something else that we're not going to be used for. And we're going to get into this a little bit more in a second. But like kind of what I was saying earlier today, without you guys, is that let's say that we also evaluated, and the idea is that we're finding solutions to all this, firstly. Let's say we evaluated it at 2 and we got 14. And then you said, oh, I wonder what this is. And then, we go through this same process and we end up saying, oh, look, it's negative 20. Like, what really awesome thing could you say that happens between 2 and 8? If evaluating at x equals 2 gives us positive 14, so that coordinate would be 2, 14. So that's true, but what is really a big deal that happens between those two numbers? Because then the other number we eventually get to 8, and it's the y value is negative 20 now. Because again, we are using, it is decreasing, but that's only kind of interesting because we're talking about solutions, and solutions of a polynomial are the same as their zeros. So what could you say if this situation happened? I just made this up. But if this situation happened, what could you say happens between 2 and 8? There has to be a 0 there. Okay? Because like you can't be in the positives and get to the negatives without crossing over the x-axis, yeah? Well, that's really a big deal. Okay, now it's not as big a deal now because you have graphing calculators and you can just look at it and you're like, yeah, whatever. But like before that, you had to do all these little tests and tricks and narrow it down and hope that you found one, and this is one of the big major tricks. And we're going to skip it because you guys got graphing calculators. So I apologize to you and your offspring. Because you may not be able to help them if they have to do this. I apologize, little Wachowski.
I definitely have that over an enchilada.
That's on video, by the way. Now you're going to have to answer to that question for the rest of your life. All right, listen. Listen. Just so that everyone knows, Wachowski's siding with the potato over the enchilada. Just so we know that. All right. Do we understand what we're finding in this section? He's on record. All right, we're finding 3 zeros, but they've given us 1 already. Now, if you're looking at this problem, how in the world could you find the other 2 if you didn't know the first one? You would try to factor it, but this one doesn't factor as is. So you would have to go through these other techniques that I keep referencing, okay, that we're not going to do. But, oh, wait a minute, I forgot about one.
Yeah, I love pregame.
Yeah, it's a little pregame. Real pregame, we just, And of course, all the symbols are used up, so our pregaming was a little different, but get a pre-party before the post-party and the party. It's a lot complicated. You guys will figure it out one day. All right, so this is a factor, so if we do all this with it, man, I missed the math parties, Wachowski.
Oh, yeah?
Yeah. I don't even even know how else to answer it.
Yeah,
I
I
do.
don't know why everyone.
They think I'm picking on you. Little do they know, I'm making you stronger. This is it's like a superhero in training. You're welcome.
Thank you.
I already said you're welcome. So it's fine. All right, sweet. They did give us the correct thing, yeah?
Yep, looks like it.
All right, so we need to find the other two though, so now what? Yeah, right, so this, yeah, thank you, good. Yeah, right, so this becomes x squared. Oh, man.
I'm not recalling.
Remember, after we did that, we were going to see until we got to the end.
Yeah, man, here I thought was all new stuff.
This is what, like, I didn't know how to do.
I didn't know the arrows.
So the arrows,
Oh, so you learned about the arrows? You're welcome, I guess.
the arrows I got.
I barely got anything. What is it then? Everybody remembers afterwards.
I thought we just did synthetic division.
What's that?
I thought we just did synthetic division.
We did we did, right here, right?
That means the other ones are 2 and 6.
No, I don't remember.
X equals -2, and then X equals
Hey, when I
6.
get a chance, I always remember the stuff that we never used. Matrices, remember those? Bruce really likes those.
Did you use matrices again though?
We haven't since we learned them. I
Yeah,
like-
right.
I liked matrices, I like proofs.
I like
We
matrices.
never did.
I feel like she's about to drop the bomb on me, like, this stuff I don't like at all.
Proofs were the only things.
Like
that-
Bruce, like matrices, just not. Thank you.
It's the opposite way.
What's that?
X minus 2 and X minus 6. Maybe it was just like.
I think it's right.
Your senior or sophomore.
Is that right?
Negative 6 plus 2 is negative 4. Where are we going? Okay.
Is that okay?
Oh wait, this is a faster way to do.
What are we saying the other one is? I think it's really close to the same thing.
No, it should be.
All right, but these are still guesses, but that helps you get accurate. So how can you do this algebraically, which is part B? Determine one of the exact zeros, which we said was 4, and use synthetic division to verify the rest of them. So what should we do?
Put 4 and do synthetic division.
All right, so I gotta move that up. So plug in 4. I believe it's 1, -4, -2. How am I doing up there?
Yeah.
I'll make sure to use your alias since we're on YouTube here.
Gavin?
Yeah, Gavin. We doing okay, Gavin? All right. All right, here we go. 1, 4, 0. All right, sweet. We got a 0 in the remainder, which is always good. And so then this is x squared minus 2 equals 0. So now we do want to find the exact answers to the other zeros. So then we have x squared equals 2. Take the square root, plus or minus radical 2. And that's why it was only an approximation, okay, because it's an irrational number. So, right, our 3 zeros for this polynomial would be these. How's that? The best part of that is when I have to talk to Gavin's people. We can just be like, I can just press play. Like, hear all that talking? Yeah, that's Gavin. Yeah, that's Gavin. Questions? Are we all right?